So since we have that test coming up on Thursday, it's going to be over these lessons, 2.1 through 2.5, and your test is going to look a lot like this. It's not going to be exactly the same, but it's going to be the same types of questions. Okay? That as long as we can do this together, we're going to be in good shape for our test. Let me see if I can move this just slightly, I guess. Nope, not the thing I want to do. We had it right to begin with. This is what happens with it. Trying to make sure that everything fits on the screen. Okay. So, okay, this is on page 135 in your textbook in case you're wondering where to find it. There's also an assignment folder on this for Google Classroom. Okay? Who can tell me what a conjecture is? What is a conjecture? Why are we late? What is a conjecture? I would partly agree with it. A concluding, again, I'm not really fond of either wording. I'm hearing a pattern, a concluding statement. I think if we merge those two ideas together, a conjecture is that we are, like they say, write a conjecture that describes the pattern. We have to have a sentence, a conclusion really, where we're describing the pattern.
So we would say we have to find the following, like we would have to find the next.
Yes, in this case it says, then we use our conjecture to find the next item in the sequence. So I have to explain, how do I get the next item? Like, I have to describe the pattern. Based upon what I see, I have to come to a conclusion, describe that pattern. Conjecture is, I'm making that statement as to how do I find this? What is the pattern that I'm seeing? Then use it to find the next item in the sequence. So I can't just give like an answer like 36. Like that's not enough info. Okay? I also can't just do the first part and say, oh, here's the pattern. Okay, good. I need both parts in order to get full marks. So if I were to give a conjecture here as to the pattern that I'm seeing, what's happening?
It's adding by 5.
I'm adding 5?
Well, first it was like 5.
Oh, no.
It's something like, it's, for the first one, it's times 1, then times 2, then times 3, then it's get to times 5.
What's the hang up here? What's the thing that's bothering us on number 1?
The 25.
That the 25 is bothering us?
The 25.
And,
For me,
okay.
For me, it's just 5.
So some people are unsure of what's happening here. Others are unsure about what's happening here. What could lead to that pattern? So adding 5, although we see that with 5, 10, 15, it didn't work for 25. And we're starting with 5 to begin with. I also heard, okay, this is like 5 times 1, 5 times 2, this is times 3. No, sorry, that's not right either. I'm in the wrong locations. So, and let me turn some lights off just because it's going to be a little easier for people to see. Okay, that this is 5 times 1. times 2 times 3, but this would be times 5.
Oh, okay, no. So the next, I think I know the turn. So the next number would be 25, because I think what it's doing is it multiplies by 1, by 2, by 3, and then it goes to 5. So it will multiply again by 5 if we're at 5. So next time it would skip like the times 9 and then multiply by 10 2 times. I don't know, that's what I think.
I'm not sure that I'm seeing that pattern.
How is it times 3?
5 times 3.
5 times 3, 5 times, like this is 5 times 1, 5 times 2, 5 times 3, 5 times 5.
5 times 6.
I don't think that's a pattern. What other ways are these related? If I go from here to here, then here to here, then here to here.
Oh, add the previous number to the next.
Okay, so
Well,
5 to 5.
so 5 plus 5 is 10. 5 plus
Okay,
10
so
is
5
15.
plus 5 gives 10.
10 plus 5 is 15. And 10 plus 15 is 25.
Okay.
So the next one would be 25 plus 15.
Which is?
40.
I was right about that.
Do we see that pattern? Does that really kind of work here? Like, we're saying, like, originally there's a 0.
Yeah.
0 plus 5 is 5. 5 plus 5 is 10. 5 plus 10, 15. 10 plus 15, 25. 15, 25, 40. And we could continue. The next one would be 65. How would you describe that? What's your conjecture? Like, a lot of times, we have to figure out what the pattern is. And so we might actually even find the answer in order to work out what's the conjecture. How do I find that next one?
To find the next number in the sequence, you have to add the previous number to the next.
So to find the next term in the sequence, add the 2 previous numbers. Sometimes it's like instantaneous. You can look at it. Sometimes you have to start playing with the relationships. Am I adding? Am I subtracting? Am I multiplying? Am I dividing? Do I just see like skip counting? Do I have to see, how previous terms are related? There's several things that I'm going to have to check. So the conjecture is to find the next item in the sequence, add the 2 previous numbers. Or I could even write that as add the 2 previous numbers to find the next term in the sequence. How about this next one? This next one's a little easier, I think. A little easier on our brains. It helps that it's visual too. How would you describe, what is your conjecture? So to find the next term, Richard says add a larger square to the outside. So what's the next item in the sequence? What is that gonna look like? Mine are a little bit more like rectangles, but it's gonna look something like that. The important thing is that we see those 4 layers. So, what lesson was that from? This is from lesson 2.1. Make sure that when you have questions like this, that you do both parts. Okay? Doing one gets you half marks. That's a quick way to fail not following the instructions. Okay? And so it could be where I have to compare numbers. It could be where I have to compare visual, compare shape. Maybe both. Can I move on to 3? Anyone still working on this, that they need me to stay here? Okay. Let's move on to 3. What's a counter example? How would you describe what a counter example is? An example that proves that something is false, that something is incorrect. Okay? Example, typically we think it is, showing, something true. Counter, that means it's the exact opposite. Kind of like clockwise, counterclockwise. Okay, so we have something that is disproving or showing something false. So, if AB is equal to BC, then B is the midpoint of AC. What is a counterexample for that? What is something that would prove that one false? With a segment AC, is there a way to disprove about a counterexample or B being the midpoint?
They could be just completely separate lines. Like, there could be like, cause there are multiple planes, and there could be like, you can have one plane with AB on it, and then another plane with BC on it. And they might just be the same line. I mean, it would be rare, but it could happen.
These have to be false.
What do you mean that B would have to be false?
So does that conjecture have to be false? It could be true.
No, what we're trying to do is we are trying to prove it false. Three and 4 is just literally, when is this false? Provide the counterexample. Now I admit, I am less comfortable with this question too, and I'm less comfortable with their answer.
There's a counterexample.
Because we need to focus on this.
Oh, what if there's a point in between? Another point other than B?
But AB is equal to BC.
That can still be true.
Okay. My brain's having trouble accepting this because as soon as they start introducing this then, it automatically seems like I have a line like this, right?
Yeah.
But their answer really focuses in on that first part, that if AB is equal to BC, we don't even worry about a line like this. It could be that we have this. This is a could, but it's not necessarily, like this is a sometimes, if all the points are collinear, yes, this would mean that AB is equal to BC. But what happens if they're not collinear? If they're not collinear, I could have like two sides of a triangle where this is ABC. This is ABC. Does that make sense? This is one of these sometimes situations. So we can have AB equaling BC, but it's not a guarantee that B is the midpoint. We don't know if A, B, and C are collinear or not. And so, you know, this feels like it's misleading you because we want to automatically prove something true. We want to accept that in math, that what we're learning always is true. But it all depends on whether A, B, and C are collinear. If it were collinear, then it's true. If they're not collinear, then it's false. So A, B, and C being non-collinear points, this would be false. It's not the midpoint if we don't have everything in a straight line. Does that make sense?
We don't know that it's a straight line.
Yeah, we don't know the position of A, B, and C. We don't know if those points are collinear or not. So our counterexample that proves this conjecture false is I just need to show A, B, and C non-collinear, and they end up as two different segments rather than being two different segments on the same line. These would be two different segments on different lines. Does that make sense to you guys? Okay, how about number 4? What's a real number? N is a real number, then n cubed is greater than n.
Because it could be a negative number.
Okay, n could be a negative number. So he says, if I have a negative, give me an example of a negative number you want to use. Negative 5. So if n were negative 5, n cubed would be negative 125. Okay, is negative 5 cubed? So this is really this n cubed, and our n is negative 5.
I thought that when you cubed a negative, you would get a positive.
No, when you square it, you get a positive.
Oh, okay.
If you want another example that involves something that isn't a negative, what happens if n is 1? What's n cubed? Is 1 greater than 1? But the negatives work, the 1 works. We can come up with several different counterexamples. It doesn't have to be just the same one. All we need to do is provide an example where, hey, it doesn't work. So both of these are false because we can come up with that counterexample. In this case, we just had to say we don't know if A, B, and C are collinear or not. That if A, B, and C are non-collinear, that's not true. B is not a midpoint. if n is a real number, whether it's positive or negative, I can come up with a counterexample to prove that I don't always have a larger number when it's cubed. Okay, it could be the same or smaller. Any questions on any of that? So we know how to write conjectures. It's just explain how to follow the pattern to find the next term. Okay, and actually do that second part, find the next term. Do both. In this case, provide one example that goes against what they state to prove that this is false. Here's the next part. We're looking at lesson 2. Okay, where we start looking at compound statements. Again, we have to do more than one thing. First thing, says use the following statements to write a compound statement. Okay, my compound statement, if I'm writing it, is going to be using and or. One of those two is going to be in there, depending on what they give us. Okay? And the compound statement is going to be these segments joined by one of those. I cannot change the wording other than changing something to not, if that makes sense. I've seen in some of the homeworks that some people are trying to rewrite this. You know, like if I were joining P and Q, they would try to write $1 is equal to 100 cents and there are 4 quarters. I can't rewrite that in such a way. I need to keep these, that if it was P and Q, that it would simply be this part and this part. Don't rewrite it. Does that make sense? Conjunctions, all I'm doing is I'm taking like 2 Lego bricks and then connecting them together with a third. I can't change the shape of that segment. I can't change what it's saying. Okay, I'm not trying to rewrite it. So really, please do not. Now, it is a little bit different if we talk about this and we find that we have something like not R, and I have to say February is, and I have to insert not the month before January. Like, I can change it for that. I can say not or is not, isn't, does not. That's the only rewording that you're allowed to do. Does that make sense, guys? I just really want to be clear on that. Now, what does this mean here?
And. Or.
And.
Or. The upside down.
This one means or. What does that little squiggly mean?
Not.
Not. So that's when I have to reverse. I have to say the opposite. Okay? So let's write the compound statement for number 5. So I start off with $1 is equal to 100 cents. What comes next? And or. And I like to sometimes underline it or even put it in capital letters just so that it calls attention to, hey, what am I doing here? The second part is the R. February is the month before January. So all I have is this part and the next part. I don't have to worry about any knots. but I do have an and. Now, is this a conjunction or a disjunction? What's the difference? Conjunction is and, disjunction is or. Okay? So this is a conjunction. Now I need to figure out the truth value and explain the reasoning. So overall, is this true or false? I'm hearing false. Because
R is not true at all. And they both need.
okay, so R, this February is the month before January. We know that one to be false. $1 is equal to 100 cents. Well, we know that to be true. So why is it false?
Because they both need to be true. For an and.
For an and, I need both parts to be true. If we're an or,
Only one.
then all I need is one. If this were or, it would be true. But this is false because I needed both, okay? Because P is true and R is false. And with and, both need to be true. Okay? I need that much information from you guys. The conjunction, that's just me, helping to identify. I'm okay if you leave that part out. But all the rest I need you to do in order to answer this. I need you to write out the whole compound statement. You can't just write half. You can't rewrite it. Okay, I need the compound statement the way it's supposed to be. And then you need to identify the parts, what's true, what's false, to work out what the overall truth value is. So this is the overall truth value right here. And this over here is the reasoning. You need to write it out. Does that make sense? I had some people in their homework that, really, they were asked to do this, and you know what I got in response? What does that mean? Like, you'd make a guess that they're saying, well, the overall truth value is true, but they didn't identify anything but the compound statement. And I really don't know how they got that answer. Even if you were right, you would only get partial marks. And it's kind of hard if it's a 50-50 chance on all of your questions, that if all you did was half of it, that's going to look really bad for your test grade. Would we agree? So I'm looking for this. Okay, and if you can try to follow the same pattern all the time, great. If you can call attention to things by adding boxes and circles sometimes, that can help for you and for me, so I can scan through really quick. But you want to keep things in a very organized manner on your paper, okay? Let me know for each one what question you're doing. Keep all of your work in that area. Keep it organized. You don't get a prize for using less paper. Okay? How about number 6? Okay, so I'm already hearing from Richard up front. I'm going to use you as an example. He says true. I'm like, well, is that the first part you needed to do? Do go step by step. Like literally start with number 1, then number 2, then number 3. Write the compound, find the truth value, explain. So let's start with the compound, right? Okay, so he says that this is also a conjunction. What is the conjunction? A dollar is equal to 100 cents. And there are 4 quarters in a dollar. I need this whole thing written down for you to actually write the compound statement. You can't skip. You can't rewrite. All you do is you join using and or. But write out the whole thing. Okay? Now Richard earlier said, hey, this is true because, but he didn't give us the because. Why is this true? Well, we need both parts to be true, right?
Those are both bad.
Both of these are true statements because P and Q are both true statements. So I need the compound, I need the overall truth value, and I need to know why that overall truth value is what you say it is. Does it seem extra? It does a little bit. You know, you think, well, hey, I could write that because I've already figured that out. Why do I have to write it out? It's kind of like, you know, checking over your work. Okay? That, you know, when you go to write it out, sometimes you think, oh, wait a second, I thought. It's checking things over and it's showing your understanding of things. And if you're asked in the question to do so, I have to do it. Okay, and it's going to be set up this way for the test. Writing the compound, finding the truth value, and explaining why that truth value is what it is. Okay, number 7. Oh, they never even gave us an or, did they? We have and once again. A dollar is equal to 100 cents. And once again, because they show that pointing up, we need not are. February is not the month before January. Okay? Is this true or false? True. Why? This part, this first part, P, is true. And not R is true. Because both P and not R are true. So we had true, true. You stopped writing. Do we have any of these be false?
No.
First one.
Oh, yeah.
The first one is false. Now if we change this so it was the other way around,
It would just be like the last one.
if we change this so it's the other way around, that it was P or R, what would the truth value be then?
True,
It would be true. Why?
because P is a true statement. Or I just gotta have true.
Okay, so if 5 had stated that we had P or R, This is P or R. This part was true, this part would be false, but the overall truth value of this would be true, because in or situation, all I need is one part of it to be true. Have we got that? So be careful in making sure that you show all the parts that you're asked to do. Show me the entire compound statement. Make sure that you haven't rewritten anything. Find that truth value and explain. Okay, copy and complete the truth table. Okay, if we have Q with these values, what are my not Q values? How can I figure out what the not Q values are based upon Q? Just reverse, because not Q is the opposite. So we have true, false, true, false. Now this asks for P or not Q. Now all I need is one part of it to be true for all of it to be true, because we're dealing with or. Okay? So P or not Q. We don't even have to worry about this part at this point. We're just comparing D's. As long as we have one true value, this is going to be true. True and true, true. False and false, false. False and true, true. True and false, true. Do we follow?
He will.
Yeah.
Wait, hold on, what did you just belong to, Q?
I'm just saying, we don't even really have to worry about that when dealing with this final line. I wouldn't really put it there. I'm just saying it was not necessary for us to consider in filling out this last column. Does that make sense? It's still important in the fact that we need to know these values to figure out these next values. Okay, so we're dealing with two statements to begin with. We know whether things are true or false. But then we have to consider the not Q situation, so it's going to be the opposite of Q. And then we're comparing in our disjunction here, this compound statement where we're looking at P or not Q, where all we're doing is we're comparing this column here and this column here to get to our final answers. Okay, I'm going to switch math. This one's really bugging me. It's falling down in comparison. See if this one works a little bit better for me. Okay. So what part seems to be a little bit tricky so far? What do you think, Elijah? What part is harder to see where it's coming from? Or do you just want me to go through the whole thing again from the beginning?
No, I know what it is.
You know how to do that one? Okay. It's not necessarily apparent to most people. It just seems like, oh, we're putting in random, true or false. Okay, but what we're looking at is we have a statement, we have a second statement. We're looking to see, okay, if this is true, and this is not true or false, there is not a specific order to it. Like, it is possible that we could have looked at the false situation and false and false and true and false and true. Like, it could be in any order, but you got to make sure that you've considered all situations of if this is true You know, we considered all permutations. But this part was needed so we could figure out this one, and we need this one and this one to figure out our final, as we're doing our comparisons. And so it's important to have each of those columns there as documentation so that you can make sense of this final answer. Don't try to just do this in your head. You might be able to, but if you're trying to keep it all in your head, you're probably going to screw up, at least in one place. Okay? Writing things down is a good thing. Okay, I think we might be able to get another one or two done here. Okay, hypothesis and conclusion. We have to look at these conditionals in 9, 10, 11 to identify which part is the hypothesis and which part is the conclusion. So there's different ways that I could write that out. Okay, I can look at the different parts, you know, once I write it out, and just break it apart and label. Or I could say, looking at this, I could say, hypothesis, conclusion, and then write it out. Either which way would be okay. Which part is my hypothesis for number 9? If a polygon has 5 sides. We know that because we started looking for this. What's my conclusion? Then. So here's my hypothesis, here's my conclusion, and I could put these right here. Okay, if I want to write it out that way. How about for number 10? Pretty simple still, right? If, then. Hypothesis, conclusion. How about 11? If, sorry, it says an angle with a measure less than 90 degrees, an angle with a measure less than 90 is an acute angle. Can I rewrite that if then? If an angle has a measure less than 90 degrees, then it is an acute angle. And if I do that, I have hypothesis. If an angle has a measure less than 90, conclusion, it is an acute angle. Yeah, it definitely seems like a good place to stop. So we pick up here tomorrow looking at number 12. Not a bad place.